A James Webb revelation that came as a surprise has captivated the scientific community's ability to identify urban light signals originating from space. Contained an astounding 7 billion kilometers away from Earth. This discovery opens new possibilities in the search for extraterrestrial life by concentrating on Proxima Centauri b, the closest known exoplanet to Earth. The telescope discovered strange, bright lights radiating from its surface. What might be causing these mysterious lights on Torbi and Proxima? Could they communicate the existence of life other than ours? For years, humanity has yearned and searched for signs of life in the vast expanse of space, and any indication suggesting such a possibility has always generated great excitement. The community was shocked when the James Webb Space Telescope delivered enticing evidence of life forms in the cosmos, while exploring the universe and transmitting vital data back to Earth. Strange urban lights were detected by the telescope from Torbi and Proxima, an exoplanet in a distant star system. These lights are the first of their kind ever seen in space, appearing like a far-off city illuminated against the cosmic backdrop. The idea of a distant civilization existing in the Proxima Centauri system has left scientists puzzled, filling them with awe and wonder. Many are amazed by the possibility that intelligent life forms may have developed societies far beyond our comprehension, and that we are only beginning to learn about them. As scientists examine the light, coming from a distance of 7 billion kilometers, NASA engineers wonder how long these lights have been glowing in space, perhaps waiting for humanity to develop the essential technology to detect them. David Kipping, an astronomer from Columbia University, describes Proxima b, the exoplanet, where these urban lights have been observed as a celestial body with unusual heat patterns that differ from those seen on other planets. While typical rocky planets absorb sunlight and release infrared radiation, Proxima b displays a markedly different behavior when interacting with its star, Proxima Centauri. This distinct behavior has made it an ideal subject for the James Webb Space Telescope. Its advanced infrared capabilities are highly sensitive, and the thermal signature of Proxima b will be key in uncovering the secrets of its atmosphere, taking advantage of the most cutting-edge infrared imaging. Researchers plan to investigate the planet's atmospheric mysteries and determine whether it might be able to support life. The James Webb Space Telescope, with its great infrared sensitivity, is ideally suited for probing Proxima Centauri b, as it can detect even the faintest light signals. Its narrow frequency band, 1,000 times narrower than starlight, makes it capable of detecting artificial lighting, an invaluable tool in the search for extraterrestrial life. Proxima b's intriguing connection between its surface features and interactions with its host star further enriches its appeal. The planet's daytime side may be covered with solar panels that capture energy from its star, while its night side experiences extreme cold. The temperature difference, combined with the planet's atmospheric composition, provides an intriguing area of study for astronomers. Additionally, the telescope can effectively measure the planet's thermal emissions, providing important information about atmospheric properties. The JWST's orbit, which is in sync with Proxima b's rotation, ensures thorough evaluations of both its daylight and nighttime cycles. These observations span 11.2 Earth days, giving scientists a unique opportunity to examine the planet's entire rotation. The next major step will involve analyzing the atmospheric chemistry of Proxima b to see if it has the potential to support life. This will focus on gases such as oxygen, methane, and water vapor, considered essential indicators of habitability. If these gases are detected in the atmosphere, it could suggest that the world has conditions favorable to life. However, this task is extremely difficult, as it requires capturing and analyzing the light passing through the planet's atmosphere. Although the James Webb Space Telescope is highly capable in studying planetary atmospheres, it faces limitations, particularly in detecting oxygen, a vital life indicator. Still, it will search for other elements like ozone, which could offer Further clues about the planet's potential: habitabily. It's important to note that the JWST cannot investigate every possible habitable world, as its capabilities are limited to observing only the closest exoplanets. For more in-depth investigations, astronomers are relying on ground-based observatories such as the Extremely Large Telescope, ELT, expected to begin operations in 2028. This facility will enable deeper investigation of distant exoplanets and will complement future space missions. While the JWST has some limitations, it remains an essential tool for unraveling the mysteries of distant planets. Future missions will aim to overcome difficulties such as reducing the glare of host stars to better study light reflections directly from exoplanets. This process will help researchers differentiate between gases produced by lifeforms and those generated by geological processes. Despite these challenges, scientific progress continues to advance. The James Webb Space Telescope is a pivotal step forward in our understanding of distant worlds and the broader universe. After decades of studies and in-depth searches for life across the cosmos, the question still lingers: are we truly alone in the universe? The search for life beyond Earth is one of the most profound endeavors in modern science. With each new discovery, whether large or small, the mystery deepens and yet the excitement grows. Proxima's and Torbi's mysterious lights, captured by the James Webb Space Telescope, have added a thrilling new layer to this ongoing search. If these lights are indeed artificial, it may alter our understanding of life in the universe forever. The implications of such a discovery are monumental, suggesting that life and potentially intelligent civilizations may be significantly more common than previously thought. The possibility that advanced technological civilizations could exist millions of light years away challenges everything we know about space, time, and the development of life. While it's still early days in the investigation, the urban light signals observed on Proxima and Torbi provide a remarkable clue. Because Proxima Centauri b is located just over 4 light-years away from Earth, it remains a prime candidate for further study. The telescope's ability to detect subtle signs of artificial light from such a distance is a testament to the progress humanity has made in space technology. As scientists continue to analyze data from the James Webb Space Telescope, they will focus not only on the urban lights but also on other important atmospheric indicators that could point to life. These include variations in the planet's temperature, which can offer important clues about its atmospheric composition, and potential habitabily. As more data is gathered, researchers will refine their models and hypotheses, working toward answering one of humanity's oldest questions: are we the only ones in the universe? Space organizations like NASA and other global partners are intensifying efforts to develop even more sophisticated telescopes, ensuring that our search for life continues to push the boundaries of exploration and discovery. Observation technologies: the next wave of telescopes, like the enormous Extremely Large Telescope, ELT, will offer unprecedented resolution and the ability to study distant exoplanets. This will provide, in much greater depth, invaluable insight into the conditions on planets like Proxima Centauri b and others that might possess the potential for life. While the James Webb Space Telescope JWST has already made history with its discoveries, its journey has only just begun. The incredible capabilities of the telescope will allow for ongoing exploration of distant worlds, providing a deeper understanding of how planets shape, change, and possibly develop the conditions essential to living. Each new discovery brings us closer to answering questions that have fascinated humans for centuries, as well as observing the lights coming from Proxima Centauri b. Future missions will focus on gathering even more data about the planet's atmospheric composition. Researchers are particularly intrigued by the presence of key gases such as oxygen, methane, and carbon dioxide, which are frequently connected to biological processes. These gases, if detected, could serve as biomarkers suggesting that life may indeed exist on this far-off exoplanet. Detecting these gases, however, is no simple task. Its challenge lies in isolating the faint signatures of gases from the overwhelming light of their host star. The next generation of space telescopes will likely be able to address this problem by allowing more precise measurements of the chemical makeup of distant planets' atmospheres. This progress will be crucial in determining whether planets like Proxima Centauri b, or similar worlds, have the right conditions to allow life to flourish, as astronomers and researchers continue to explore these possibilities. They are also keenly aware of the limitations of the James Webb Space Telescope. Despite its revolutionary nature, it cannot investigate all exoplanets, and its observational capacity is limited to certain types of stars and planets. To broaden our understanding, ground-based observatories will play a critical role in complementing the telescope's work, offering new ways to analyze distant worlds in greater depth. The future of space exploration is incredibly exciting. With advanced instruments like the JWST, the ELT, and other upcoming technologies, we are on the brink of responding to some of the most profound questions. Could there be other worlds with civilizations waiting to be discovered? Or are we, in fact, the only sentient beings in the vast universe? Only time and continued research will tell as we venture deeper into the vast void of space. Each breakthrough brings us one step closer to understanding the full scope of the universe and our place in it. Recent findings from the James Webb Space Telescope offer hope that we may not be as isolated as once believed. The discovery of urban-like lights on Proxima Centauri b has provided a tantalizing glimpse into the possibility that intelligent life might exist beyond Earth, challenging the long-held notion that we are alone in the universe. The excitement surrounding these unusual light signals is grounded not only in their mysterious nature, but also in the sheer implications of such a discovery. The idea that a distant world could host a thriving, advanced civilization raises profound questions about the existence of life elsewhere. Could we be looking at an alien society that has managed to thrive in ways similar to humanity's development? If these lights truly originate from an intelligent source, it could signify the start of a new era in our exploration of the cosmos. The evidence, however, is still preliminary, and scientists are cautious in their interpretation. Nevertheless, the fact that these lights are being detected from such a distant exoplanet is a breakthrough in itself. It signals that our technology is advancing to a point where we can detect even the faintest emissions from alien worlds. The James Webb Space Telescope's ability to capture such dim light and investigate its origins is a testament to our accomplishments in space exploration. Looking ahead, scientists will continue to monitor Proxima Centauri by using every tool at their disposal to gather additional information. One of the most critical next steps will be to conduct detailed studies of its atmosphere, focusing on the composition of gases such as oxygen, carbon dioxide, and methane. These gases are frequently associated with biological processes on Earth, so their presence in an exoplanet's atmosphere could provide strong evidence of life. The study of exoplanet environments is still in its infancy and remains a complex, highly technical endeavor. The main challenge lies in isolating the faint light passing through a planet's atmosphere from the overwhelming brightness of its host star. As astronomers improve their methods and create new instruments, they hope to detect even more subtle signs of life or habitability. The James Webb Space Telescope is particularly well suited for this job because of its advanced infrared capabilities. By focusing on the infrared spectrum, the telescope can detect light signals and heat emissions invisible to other telescopes. This sensitivity allows it to study the chemical makeup of exoplanet atmospheres with greater precision, providing new insights into the potential for life beyond Earth. However, as powerful as the JWST is, its abilities are still limited in certain areas. For example, detecting oxygen, a crucial indicator of life, remains a challenge. Oxygen is a reactive gas that does not persist in an atmosphere without a constant replenishment source, typically from biological activity. while the JWST can detect gases such as carbon dioxide and water vapor. Its resolution limits its ability to detect oxygen in some cases. Nevertheless, the search for life will continue through many avenues, with other observatories and future space missions playing an important role. In addition to the JWST, ground-based observatories, such as the Extremely Large Telescope, will provide complementary data. The ELT, set to begin operations in the near future, will offer a much larger aperture and improved resolution, allowing astronomers to study distant exoplanets in unprecedented detail. With the combined efforts of ground-based and space-based observatories, scientists will be able to build a more complete picture of the conditions on planets like Proxima Centauri, bringing us closer than ever to answering the ultimate question of whether we are alone in the cosmos.